To ancient astronomers, Mars appeared as a wandering star with a menacing red glow. This ominous color likely led the Babylonians to name it Nergal, the king of conflicts. The Greeks and Romans followed suit, naming it after their god of war, Mars in Roman mythology. With the invention of telescopes and improved knowledge of the solar system, a new understanding emerged. Mars was revealed to be a planet with a day similar to ours, just over 24 hours, and features resembling those on Earth: polar caps, surface markings, and clouds. This discovery excited observers, suggesting that Mars, far from being hostile, might be a sister world with the potential for water and even life. Extreme dust storms and temperature swings. When Mariner 9 arrived at Mars in 1971, scientists were eager to capture the first detailed images of the planet's surface. Instead, they were greeted by a Mars-shaped blur as a massive dust storm enveloped the entire planet, revealing only a few mountain peaks. Unlike Earth, Mars doesn't experience water-powered storms such as hurricanes or blizzards. Instead, it endures extreme temperature fluctuations and an abundance of dust, creating a unique and challenging climate. The Martian atmosphere is about 1% as dense as Earth's and retains very little heat from the distant sun. Temperatures can drop by 100 degree counts, 38 degree counts, from day to night. At noon during summer at the equator, temperatures can reach a comfortable 68 degree Celsius, 21 degree Celsius. But on a winter night at the poles, they can plummet to minus 243 degree Celsius, 153 degree Celsius. These extreme temperature variations generate winds averaging about 19 miles per hour, 31 km/h, which can escalate to 100 mph, 161 mph during major storms. However, the thin atmosphere means these winds are not very powerful. A 75, 120 km/h gust on Mars would feel like an 8, 13 km/h breeze on Earth. The storm depicted knocking astronauts around in the movie The Martian is purely a cinematic creation. Why is Mars called the Red Planet? So why is Mars called the Red Planet? Mars is famously known as the Red Planet due to its striking rust-colored appearance. This distinctive hue is caused by iron-rich minerals in its regolith, the layer of loose dust and rock that covers the planet's surface. Unlike Earth's soil, which also qualifies as regolith but contains a significant amount of organic material, Martian regolith is predominantly inorganic. According to NASA, the iron minerals in this regolith undergo oxidation or rusting when exposed to the small amounts of oxygen present in the Martian atmosphere. This oxidation process results in the soil looking red. Furthermore, the thin Martian atmosphere, composed mostly of carbon dioxide, contains trace amounts of water vapor, which aids the oxidation process over geological timescales. The fine dust, rich in iron oxides, often becomes airborne during the planet's frequent dust storms, contributing to Mars's reddish appearance even when viewed from Earth. This iron oxide-rich dust not only coats the surface, but also permeates the atmosphere, reinforcing Mars's identity as the Red Planet. Mars's iron oxidation. Mars, being smaller than Earth, is thought to have had a higher surface iron content because it did not undergo as much differentiation as Earth did. This means that less of the iron on the surface sank to the core due to Mars's lower gravity. Consequently, Mars had a comparatively higher percentage of surface iron to oxidize. Evidence from various rovers has shown iron meteorites on the Martian surface that are shiny and unoxidized, indicating that the rusting process is no longer active. One theory is that Mars once had water oceans, which would have added significant amounts of water vapor to its atmosphere. Due to Mars' lower gravity, this vapor would have reached much higher altitudes and in greater concentrations than on Earth. This high-altitude water vapor would have been exposed to ultraviolet radiation from the sun, causing the water molecules to break down and release free oxygen into the atmosphere. Free oxygen combined with metallic iron results in rust. However, for Mars to have turned red, a substantial and persistent amount of free oxygen would have been necessary to oxidize the iron-rich surface, raising questions about whether there was enough water vapor to account for all the oxidation. There are other competing theories for the rusting process, but it is clear that whatever caused it, the oxidation process efficiently turned the entire planet red. Bad Moon's rising of Mars. In 1877, American astronomer Asaph Hall discovered Mars's two tiny moons after a persistent nightly search. He named them after the attendants of the god of war, Phobos, fear, and Deimos, terror. These moons are among the strangest in the solar system. Phobos, the inner moon, orbits Mars at a close distance of only 3,521 miles, 5,189 kilometers, circling the planet from west to east 3 times a day. Deimos, farther out at 12,470 miles, 20,069 kilometers, orbits Mars once every 30 hours. Both moons are small. Phobos is 14 miles, 22 kilometers wide, and Deimos is only 8 miles, 13 kilometers across. They are locked in synchronous orbits, with one face always directed toward Mars. Scarred and lumpy, these little satellites resemble asteroids. It's possible they began as asteroids, captured by Mars's gravity in the early solar system. However, their stable orbits suggest they might be remnants from Mars's formation, or chunks of Martian rock ejected into space by a collision. This is supported by the fact that Phobos, in particular, shows evidence of impacts, such as the large Stickney crater. Due to its proximity to Mars, Phobos faces a unique fate. Its spiraling orbit brings it 6.6 feet, 2 meters, closer to Mars every 100 years. In 30 to 50 million years, Phobos will either crash into Mars, creating a massive crater, or break apart into a ring like those around Saturn. In the meantime, some believe these moons could serve as ideal way stations for Martian exploration. Their bulk could protect humans from solar radiation if they dug in, and explorers could set up laboratories to remotely control operations on Mars from these moons. The second smallest planet. Mars, with a diameter of 4,217 miles, 6,579 kilometers, is smaller than Earth, making it the second smallest planet in our solar system after Mercury. Despite its smaller size, a day on Mars is remarkably similar to a day on Earth, lasting 24 hours and 37 minutes. This near parity in day length has significant implications for future human exploration and potential colonization, as it offers a relatively familiar cycle of daylight and darkness for those who might live and work on the red planet. The diverse surface of Mars. Both hemispheres of Mars, east and west, exhibit a stark north-south dichotomy of smooth and rough terrains. The eastern hemisphere is dominated by a rugged, cratered surface, evidence of the planet enduring numerous impacts in the early years of the solar system. With the loss of its water and atmosphere, there has been nothing to erode the sharp edges of these craters. Several prominent features stand out in the eastern hemisphere. The first Martian surface feature ever observed from Earth is located here. In 1659, astronomer Christian Huygens noted an immense dark region at the center of this hemisphere, now known as Syrtis Major Planum. Huygens used the appearance and disappearance of this dark spot to estimate the length of a Martian day. Initially thought to be a plain, Syrtis Major is now recognized as a vast low-shield volcano covering 309,000 square miles, 800,000 km². Within this area, Jezero crater shows markings that may have once been water channels and is the targeted landing site for NASA's Mars 2020 rover. South of Syrtis Major lies the paler Hellas Planitia. Spanning 1,400 miles, 2,250 kilometers in width and about 4.5 miles, 7 kilometers in depth. It is one of the largest impact craters in the solar system, likely created by an asteroid impact in Mars's early history. Scientists are particularly interested in this basin because thick layers of water ice appear to be buried beneath its floor. Encircling the Martian North Pole is a smooth terrain ring known as Vastitas Borealis. This area may have once held an ocean in the early history of Mars. Today, it still contains water ice within its craters, and snow may fall on its plains in winter. Near the North Pole, Olympia Undae is a vast field of frosty sand dunes extending about 684 miles, 100 kilometers. Conversely, the South Pole is a sort of spacecraft graveyard, with the Mars 2 craft, Deep Space 2 probes, and Mars Polar Lander all having crashed in this region. This color-enhanced image of Jezero crater highlights differences in soil composition. Opposite, the surface of Syrtis Major Planum is covered in dark dust and old lava flows. Mars clearly suffered impact after impact in its early years. Seasonal changes on Mars. The axis of Mars is tilted at an angle of 25 degrees, which means the planet experiences seasons similar to those on Earth. This axial tilt causes different parts of Mars to be closer to the Sun at various times during its orbit, leading to seasonal variations. Just as on Earth, these changes in sunlight exposure result in shifting weather patterns and temperatures throughout the Martian year. During Martian summer, the hemisphere tilted towards the Sun experiences warmer temperatures and increased solar radiation, while the opposite hemisphere endures the cold of winter. Spring and autumn bring transitional periods with moderate temperatures as the planet's axial tilt causes the Sun to shine more evenly across the equator. These seasonal changes can affect the planet's surface and atmosphere, influencing dust storms, polar ice cap changes, and potential water vapor movement. Contrasts in Mars' Western Hemisphere. In the vast expanse of Mars' Western Hemisphere, a captivating story of geological wonders unfolds, painting a picture of the planet's rich history with vivid detail. Deep within Hebes Chasma, a deep trough cuts into the Martian surface, plunging down nearly 5 miles, 8 kilometers. At its center sits a striking mesa, its flat top shaped by the relentless forces of wind and water over countless years. Moving northwest, we come across Amazonis Planitia, a sprawling plain that formed around 100 million years ago from lava flows spewed by Martian volcanoes. This vast expanse stretches as far as the eye can see, a testament to the power of volcanic activity shaping the Martian landscape. In contrast, Acidalia planitia presents a rugged terrain marked by ancient scars and rough textures. The surface hints at a tumultuous past where minerals suggest the presence of hot springs and steam vents long ago. Continuing our journey southwestward, we encounter Margaritifera Terra, a region marked by a patchwork of jumbled terrain and ancient river channels. This chaotic landscape hints at a time when water may have flowed freely, sculpting the land into intricate patterns. Yet the most breathtaking sight awaits us at Valles Marineris, a colossal canyon system stretching over 2,500 miles, 4,023 kilometers along Mars's equator. Its towering cliffs plunge to depths of over 4 miles, 7 kilometers, dwarfing even Earth's Grand Canyon. Within this vast chasm, smaller canyons called chasmas extend for hundreds of miles, with Coprates Chasma alone spanning over 600 miles, 966 kilometers. Here, amidst the rugged beauty of Valles Marineris, evidence of ancient water flows adorns the canyon walls, offering a glimpse into Mars' tumultuous past. These majestic landscapes stand as monuments to the planet's ever-changing and dynamic nature.